Hi and welcome to a run through of some problem solving questions looking at the new GCSE. So with Hannah's Suites and problems like that we've had in the previous years, it looks like the GCSE syllabus is trying to create more of a kind of Singapore maths style problem solving element to its curriculum. And what we're going to do now is look at a few of the higher order skills that are required at GCSE now. Hopefully, after a few of these slides, you can pause the video and then kind of try your own solutions. But I'll go through each question after reading it out, and then you can hopefully see that these are just more of a training, a way of thinking rather than making it really, really tough, as it might actually seem, at least initially. So looking at question 1, we have a problem similar to the Hannah Suites problem a few years back, where there are n sweets in a bag, 4 of the sweets are green, the rest of the sweets are blue. Mr. Brown takes at random a sweet from the bag, he eats the sweet. So this part tells me that it's going to be a changing probability question. Mr. Brown then takes at random another sweet from the bag, he eats the sweet. The probability that Mr. Brown eats 2 blue sweets is 1/3. Find the total number of sweets in the bag. Okay, so we're not actually told how many sweets are in the bag, so the number of sweets, let's just call that n. Rather than drawing a whole tree as well, think about what we're actually looking for. So the clue is in this part of the question here, where it says the probability that Mr. Brown eats 2 blue sweets is 1/3. Okay, if you know your probability trees, we don't need to draw this, but I'm illustrating this just for helping your understanding. It would be, it's green, the rest are blue, so it could be green, blue, and then if we're calling up as G, then that's going to be green, 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 blue, and then green, blue here. But we don't need to draw all this or work out all these probabilities. All we really need is, as the question says here, 2 blue sweets. So we know whatever the blue sweet probability is, as we're going down or along the probability tree, we're timesing. So the blue probability the first time and the blue probability the second time you take a sweet, multiply them together, and that makes 1/3. And that's going to give us an equation which will end up being a quadratic that we can actually solve. So let's start with the probability of the first blue, so blue number 1, is going to be, if there are n sweets in a bag, 4 of them are green, then it's the number of sweets minus 4, as 4 of them are green, so the probability of them blue, as the rest of them are blue, must be the number of sweets overall, take away 4. So n minus 4 over n, the number of sweets in the bag. So the probability of the second pick being blue is going to be, well, takes a sweet from the bag, he eats it, blah, 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 but we want 2 blue sweets. So remember in your probability tree, if we're going blue then blue, to find out here our second blue, so this, our second blue, he's already picked a blue. So that means there is 1 less sweet in the bag, so n minus 1. And we've got n minus 5 here, because however many there were, there is now, as you've already picked a sweet out and eaten it, there is now 1 less. So instead of n minus 4, it's going to be n minus 5. So your probability on the tree would look like n minus 4 over n, and this would be n minus 5 over n minus 1. Okay, so hopefully that makes some sense. N minus 1 again because there's 1 less sweet in the bag, and n minus 5 because you've already taken out a sweet. So if it was blue or green, doesn't matter, you've still got 1 less sweet in the bag. Well, if it was green, then it would be n minus 3, but we've got 1 less sweet in the bag, so it's n minus 5. So n minus 4, and I'll write it up here, n minus 4 over m, multiplied by n minus 5 over n, and we know that the probability is 1/3. Okay, if you've got this far, then, sorry, n minus 1. Okay, so that one was n minus 1 over there. If you've got that far, then you're on a very good path, in fact. we just need to simplify this and then solve the quadratic that will come. So multiplying fractions, remember, is the top times the top. So we've got n minus 5 multiplied by n minus 4, which if we expand this quadratic would give us n squared minus 4n minus 5n would be minus 9n. Minus 4 times minus 5 is plus 20. Over, and then we've got at the bottom here, so it's going to be over n, open brackets, n minus 1. So expand that and it's going to be n squared minus n. And we know that that equals 1/3. So to get rid of the bottom of a fraction, we multiply both sides by what's on the bottom. So we're going to multiply both sides by n squared minus n. So we're going to end up with n squared minus 9n plus 20 equals n squared minus n over 3. Okay, so we've just multiplied both sides by the denominator on this side of the equation, so that gives us, from here we multiply both sides by 3, as the denominator of this side is 3, and that will give us, I'll just actually do this all on one line so we save some space. So it would be 3 multiplied by all of this, multiplying both sides by 3, and that would get rid of our denominator here. Now if we expand this bracket, 3n squared minus 27n, 3 times minus 9, and plus 60, 3 times 20, equals n squared minus m. Now let's set this, if you see this quadratic here, if you see anything like this in your exam, your first thought should be, let's set this equal to 0, and then we can try and solve the quadratic, because we've got a quadratic equation here given by the term that is squared. So if we minus n squared and add n on both sides, that will give us 2n squared minus 26n, as we're adding n, plus 60 equals 0. So to finish off, 2n squared minus 26n plus 60 equals 0. First of all, if we half every term, notice that they're all even numbers, so let's try and half it, because it will simplify when we simplify the process of factorization. So it's not obviously minus 60, it's going to be minus 30, sorry, plus 30. So it's going to be n squared minus 13n plus 30 equals 0, and that factorizes to two numbers that multiply together to make 30 but add together to make minus 13 will be minus 10 and minus 3. So now the problem is either n must be equal to 10 or n equals 3. However, one of these is a ridiculous answer because, as the question says up here, 4 of the sweets are green. So if the number of sweets in the bag to start off with is 3, then it's impossible that 4 of them are green, unless you had some sort of owing someone situation. So hypothetically, let's just simplify it. It cannot be 3 because there are 4 green sweets in the bag. Therefore, the number of sweets is 10 in the bag. Looking at our second problem solving question now. There are X beads in a box, 5 are red and the rest are yellow. Emily takes a bead at random, notes the colour and puts it back in the box. Okay, so puts it back in the box is very important. That's going to tell us that the probability is going to be the same for the first and second take of beads. So Emily then takes a second bead, the probability that both beads will be different is 4 over 9. So if there are X beads in a box, 5 are yet red and the rest are yellow, let's start with our probability tree. And as we're going to be looking at more than just, like in the previous example, a blue-blue, we're going to be looking at, for example, in this one, a red-yellow and a yellow-red. Okay, so we're looking for red-yellow and yellow-red. But we know the probabilities are going to be the same each time we take a pick, given by puts it back in the box. So let's go for this one being red and this one being yellow. Therefore, this one's red and this one's yellow and this one's red and this one's yellow. So the probability of it being red, if 5 of them are red and the next are yellow, then it's 5 over x, because there are 5 red in the box and x beads overall, so it's 5 of x. Therefore, probability of it being yellow is x minus 5 So the total number of beads minus 5, because 5 of them are yellow, sorry, 5 of them are red, over x. So that's our probability the first time. Now we only need to focus on the next probability of it being yellow down here, and the next probability of it being red up here, because we want the probability that they are different. So if they put them back in the box, that means the probability of it being yellow is going to be x minus 5. X minus 5. Put it back in the box, so the probability of it being yellow again is going to be x minus 5. So x minus 5 over x, and the probability of it being red is going to be 5 over x. Put the beads back in the box, so the probability of being red is the same each time, and yellow the same each time. So what you can see here, if you're used to doing probability problems, we're actually going to be multiplying the red by the yellow, so this probability here, and then this yellow by the red. Note that because the probabilities are both the same, you can actually just work out what it is one time and then double it. Okay, because we're going to end up with the same probability each time. However, just in case you didn't really get that in the example that you've tried doing, I'm going to work out the probability each time and then add them together. So we know the probability of being red then yellow, and then yellow then red, add together to make 4 over 8, because those are the two combinations where both beads will be different. So we've got 5 over x multiplied by, and I'm going to do my multiply by sign as a dot, just to try and avoid confusion, because we are multiplying and using x's for our unknown value. So it's 5 over x multiplied by x minus 5 over x equals 4 over 9. Okay, and we're actually going to have that again down here. So x times x, x squared, and on the top 5 times x, so we're going to have 5 times x minus 5, which if we expanded that would be 5x minus 25 equals 4 over 9. However, remember, it's going to be two lots of these added together to make 4 over 9. So it's not actually strictly true that we've got 5 over x multiplied by x minus 5 over x equals 4 over 9, because we're going to have to double it. So we're going to have two lots of these to make 4 over 9. Okay, so again, because we're going red, yellow, and then yellow, red, and we're going to add them together, we're going to end up with 4 over 9 there. So we need to double, as the odds are the same, we need to double whatever we got for multiplying it along the chain once. So we could actually deal with that by expanding that bracket to make it 10x minus 50 over x squared equals 4 over 9. And remember, when we're doubling what's inside the bracket, so if I had two open brackets, x over x squared, that would be, for example, 2x over x squared, just like when you have a multiplication of a fraction, so for example 2 times a fifth, that would be 2 fifths, and you wouldn't multiply the denominator by the same thing as you multiplied the numerator by, because if we did that, you'd actually end up with 2 over 10 in this example, so we multiply both of them by 2, which would be again just the same as 1/5. So remember, when you're multiplying this bracket here, you're actually just doubling what's on the top, not what's on the bottom. So from here, multiply both sides by x squared, so 10x minus 50 equals 4x squared over 9, and then multiply both sides by 9, which would get rid of the denominator there, so we're going to have 9 times all of this, so 90x minus 450 equals 4x squared. And again, we're in that situation where you should be able to recognize that we've got a quadratic. So with the quadratic, we should try and aim to set it equal to 0 so we can solve it. As we've got a positive x squared on this side, let's eliminate everything from this side. So take away 90x and add 450, which I'm going to write up here as 4x squared minus 90x plus 450 equal to 0. Now notice they're all even numbers, so we can half them. simplify first of all. So 2x squared minus 45x plus 225. So from here we will look at factorizing. So 2 times 225 is going to give us 450. So we need numbers that multiply together to make 450, but add together so have a difference of 45. So 0 equals, and then we'll put our brackets in there. And it's going to be, if you notice that 45 and 450, if we do 30 multiplied by 15, and it's going to have to be minus 30 and minus 15. So we've got x minus 30, x minus 15. So it's going to, if we simplify that, write it over the coefficient of x squared again. X minus 30 over 2 is going to be x minus 15. X minus 15 over 2 doesn't simplify, so this 2 goes before the x to make it 2x minus 15. And therefore, our two values are x equals 15 or x equals, and this is going to have to be 7.5. As we're talking about a number of beads, it would be ridiculous to have 0.5 of a bead. We're assuming, I guess, then that you don't have broken beads. But yeah, it's going to be x equals 15. So there are 15 beads in the box to start off with. Now looking at another shape problem, trapeziums seem to be turning up quite a lot in a lot of the past papers that I've seen. I think that the area of the trapezium rule has been underused in the past. I think they're trying to rectify that, and they're kind of showing that actually they might be testing it in an algebraic sense quite a lot. So here's a problem for you. ABCD is a trapezium. EFGH is a square. And then the area of the trapezium is equal to the area of the square. Work out the value of x. Well, the square should be an easy place to start. Let's put it over here. So we'll work out our area of our square over there and the area of the trapezium over here. The formula for the area of trapezium is the sum of the parallel sides divided by 2 and multiplied by the distance between them, or height, as is more commonly known. So the parallel sides, which at the moment will be here. Remember, you could have a trapezium which looks more like that, in which case these would be the parallel sides, as you often use with the area under a graph. So the parallel sides, add them together and divide by 2, then multiply by the distance between. Okay, you might see a different version of the trapezium rule where you have a plus b, and it might be easier if you multiply by the height and then divide by 2. Okay, so you can see variations of the trapezium rule. However, we're just going to use a plus b divided by 2 and then times by the height. So a and b, if we add them together, that's going to give us 5x, and then we divide that by 2 and multiply by the distance between them. So multiply by 2x plus 2. So 5x over 2 multiplied by 2x plus 2, you might find easier if we've seen it as a problem where there is 5x over 2. Maybe it's a little bit closer, that might make it easier for you. So 2x times 5x over 2 is going to give us 10x squared over 2, and then 5x over 2 times by 2 is going to be 10x over 2, which both of these would simplify to be 5x squared plus 5x. So that is an algebraic expression for the area of the trapezium. The area of the square is going to be 3x minus 2 multiplied by 3x minus 2, or just 3x minus 2 all squared. Now with our double brackets again, so 3x minus 2, 3x minus 2, we expand those brackets, you can get 9x squared minus 6x, and then minus another 6x, so minus 12x. Minus 2 times minus 2 is positive 4. And that is the algebraic expression for the area of your square. Now, if you know that they're equal to each other, then what we can do is set them equal to each other once we've got the algebraic expressions. So let's rewrite our trapezium over here, 5x squared plus 5x, and we know that that equals the area of our square, which is 9x squared minus 12x plus 4. Right, so now we've got a decision. As you can see, hopefully, and hopefully you're getting quite sick of it now, we've got quadratics that are involved quite heavily in these problems. What we've got to do is set them equal to 0, and then we can try and factorize, or use a quadratic formula, or complete the square. So our decision now is very important. A lot of students, because they may have written, like I have here, the 5x squared over here, and the 9x squared on the other side, a lot of students tend to try and put everything on the left-hand side, or just try and get rid of all this mathematically to put it all on this side. But that is really going to be disadvantageous, because once we've got a negative x squared, a lot of students find it a lot harder to kind of deal with it. And we could multiply everything on this side by minus 1 to make it positive 4x squared. But why overcomplicate it when what we can do first is say, whichever side has the least number of x squareds, let's get rid of them. So this side here has 5x squared. If you envisage this as the middle, where the equal sign is, then this side here has 9x squared. So let's get rid of this 5x squared by subtracting 5x squared. So 5x equals 4x squared minus 12x plus 4. Now if we want to set it equal to 0, let's subtract 5x. So 5x minus 5x on this side is going to be 0. 4x squared minus, if we're subtracting another 5x, and this is going to become minus 17x, and then plus 4. So what we've got now is a quadratic, which doesn't look like it will be easy to factorize. But if we remember that if we've got a coefficient of x squared multiplied by the constant term, the last term in this case, then we want to multiply numbers together to make 4 times 4, so multiply to make 16, but add together to make minus 17. So two numbers that multiply together to make 16, but add together to make minus 17. So we're looking at numbers that multiply to make 16. It's going to be minus 16 and minus 1. Those two multiply together to make positive 16, but they add together to make negative 17. So let's write that down here. 0 equals, and then we're going to write x minus 16 and x minus 1. If you're doing this technique, remember to write them over the coefficient of x squared. So over 4, that simplifies, so x minus 16 over 4 is the same as saying, I'll just make it a little bit more clear, 16 over 4 is the same as saying 16 divided by 4, which is 4. This doesn't simplify, so we put it behind the x, and it's going to be 4x minus 1. So we have two values now. Either x can be equal to 4, or 4x minus 1. If we solve that, 4x minus 1 equals 0. Therefore 4x equals 1, and x equals a quarter. So or x equals a quarter. Now, one of these values doesn't make sense, because if you look over here, if x was a quarter, then 3 times x would be 3 quarters, and 3 quarters subtract 2 is not going to be a positive number. We're going to have a negative distance. So that wouldn't be a very sensible thing to consider when you're measuring the length of a shape. So our only value which makes sense would be x equals 4. Just before we start this problem, it might be worth mentioning that we're mentioning all these things, but what we want to find, so what should be written in here, is what is the value of x. Okay, so we've got all this, and remember that we're looking for that value of x. Okay, so that part was missing off the question. What is the value of x? So this question now is another shape problem, but it's given to you in a different way, and hopefully you'll actually find that this kind of problem solving, given away the next question, hopefully you'll see that this kind of problem solving question actually isn't too bad. We've got the facts here that ABCH, so ABC to H is a square. So we know about squares that all sides are the same length, so all these sides must be the same. Therefore, this side must be the same as well, as this is a rectangle. So HCFG is a rectangle. We know opposite sides in a rectangle are equal. CDEF is a square. CDEF is a square, so we know these sides. And remember, I can put 2 strikes through something if it is the same as every other side with 2 strikes through, and one strike through means the other sides with 1 strike are equal in length as well. So these sides are all the same length. A rectangle again, so the opposite sides are the same length. It's a rectangle, it's a square, they join up to make an L shape. So this overall L shape, which you might have been easy to see at the start, and the area of the L shape is 163 centimeters squared. So again, what we can start by doing is working out the area of this square here, the area of this square here, and then as this is 3 centimeters, we know that this length here is 3 centimeters, and as this length here is 2 open brackets x plus 3, we know that this length here is going to be 2 open brackets x plus 3. So we can start actually working out areas here. I'm going to try and annotate on the diagram. So first of all, this is 2 open brackets x plus 3 multiplied by 2 open brackets x plus 3. So maybe easier if you see this as 2 open brackets x plus 3 all squared. But to make it a bit more easy, let's expand this to get 2x plus 6. So again, just 2 times x and 2 times 3. And we know that length, which is the same as that here. So 2 open brackets x plus 3 is the same as 2x plus 6. We're actually multiplying that by itself. So this length here, which is 2x plus 6. So it's that squared. Or if you want it in double bracket, because it might be easier for you to see it, to expand, it might be easier if I draw it like that. That's the kind of way that we're a bit more used to seeing an expansion of double brackets. So you could have done 2 open brackets x plus 3 and then squared that, but it might be easier if you expanded it and then know that you're going to multiply it by the same thing, so that's the same as squaring. So therefore, if you go for your double expansion method, if you use grid method, you do it differently, but doing it this way, you get 4x squared. So I've done that one. Add 12x, add another 12x will give me 24x. And then 6 times 6 is 36, so plus 36. So 4x squared is a 4x squared plus 24x plus 36. This area here is nice and easy because we know this is a square, so it's 3 times 3, which is 9. And we know this length here was 3 multiplied by 2x plus 6. 3 multiplied by 2x plus 6 would look like this. 3 multiplied by 2x plus 6. So 6x plus 18. So now we've worked out all those areas. Let's just simplify. I'll leave just the areas here. Let's make it a little bit easier for you to see what's going on. So adding all these together, so this area, add this area, add this area. First of all, with our numbers, we're going to have 36 plus 18 plus 9, so that's going to be 27 plus 36, which is going to give us 33. 63, sorry, 63, of course. 63 plus, it's going to be the 24x plus 6x, so 30x, and then plus 4x squared. But what do we know about this? This is now an algebraic expression that we've got here. This is the algebraic expression for the area of this L shape, so all of these put together. What we're told here is that the area of the L shape is 163 centimeters squared. So that is the same as our algebraic expression. It is the area of the L shape. Once we're told this, you should try and once again set our quadratic equal to 0, and how we're going to do that is subtract 163 on both sides. Okay, so we're trying to set it equal to 0, so let's take away 163 from here, that will give us 0. I'll just write up here, and then 63 take away 163 is going to be minus 100. So we have 4x squared plus 30x minus 100. Hopefully you'll see now that these are all even numbers. Are they divisible by 4? No, they're not. No, they aren't, because we know 28, and then the next multiple of 4 will be 32. So we can divide them by 2, so we can divide both sides by 2. So every term on both sides by 2. So it can be 2x squared. 30 divided by 2 is 15x. And then 100 divided by 2 is going to be 50. And that equals 0. So what we're going to try and do here is factorize. So we want numbers that multiply together to make minus 100, but they add together to make 15. So hopefully you can see that this does factorize. Numbers that multiply together to make minus 100 but add together to make 15 would be plus 20 and minus 5. So we can do x plus 20, x minus 5 equals 0. However, remember, because we've got a coefficient of x squared, write them over 2 and simplify if you can. So x plus 10, and this doesn't simplify because 5 over 2 can't be written as a whole number, so the 5 goes behind the x, so the 2 goes behind the x, to give me 2x minus 5 equal to 0. Now our two values of x must be x equals minus 10. As we're talking about lengths here, that wouldn't make sense because we'd have in this bracket minus 10 plus 7 would be minus 10 plus 3, which would be minus 7. 2 times minus 7 minus 14. So this length we're going to say can't be negative. So that leaves us with 2x minus 5 equals 0. So 2x equals 5, divided by 2, x equals 5 over 2. So therefore, if we get rid of all of this, x equals 5 over 2. Yes, you could say 2.5, but that is what our value of x is. Question 5 now, we're looking through a shape problem solving kind of problem that you might get, which looks at the area of a shaded region given by this rectangle here minus this rectangle here. So the area of this black space is 6 centimeters squared. We've got this length here is 3x centimeters, this length here which is 4x plus 1 centimeters, this length which is 6x minus 3 centimeters, and this area here which is length here, sorry, which is 2 centimeters. So we've got to visualize this problem as one which is like a rectangle with something cut out. So this area here is cut out. So therefore we've got to see it as like when you have an A4 piece of paper and you want to work out the area of it, but then you've got some scissors and you cut out this space here. So it's going to be taking away this space here. So we want to work out the area of that and subtract the rectangle inside. So to do that, and our dimensions that you may be able to see already, we've got diagram which is not to scale. So we've got 3x along here and then 4x plus 1 here. Inherently 3x should be a smaller length unless we're talking about a negative length here, which we won't be. So this is a diagram which is not to scale. The area of the shaded region is 6 centimeters squared, so we're going to need to work out the area, like we said before, of the black rectangle and subtract the area of the white rectangle inside. So the area of a rectangle is length times width, or base times height, or whatever you want to call it. Either way, it's this perpendicular distance multiplied by this perpendicular distance. So 3x multiplied by 4x plus 1. So multiplied by 4x plus 1. And the question might not give you the brackets. If it was like that, you put brackets around it anyway, just to remind you that you're multiplying 3x by 4x and 3x by 1 as well. So we're going to have that area, which will be 12x squared plus 3x. Remember, we're doing x times x to give us x squared, 3 times 4 to give us 12, hence why we got 12x squared, then 3x times 1 to give us 3x. So that's the area of this rectangle, but we want to subtract the area of this rectangle, and this rectangle is going to be 2x times by 6x minus 3. So this area here is going to be 2 multiplied by 6x minus 3. 2 multiplied by 6x is going to give us 12x. 2 multiplied by negative 3 is going to give us minus 6. So we're subtracting 12x minus 6. So 12x squared plus 3x minus 12x minus 6. So we're going to get 12x squared. 3x subtract 12x is going to give us minus 9x. And then we've got negative 6. Okay, so remember we're subtracting all of this. So if we did have a positive 12x, then we're doing 3x subtract 12x. And if we've got a negative in there, then it's going to be minus 6, which will give us a positive 6. So all of that, remember, equals the area of the shaded region. Okay, we've worked out the area of this black space here. And it's going to be algebraically this. Yet we're told the area is 6 centimeters, so the area there equals 6. From here, as you have seen before, we have a quadratic, so we might need to think about trying to set it equal to 0 and then solving it to find what x is. First of all, to set it equal to 0, we need to subtract 6 on both sides to make this positive 6 into a 0, and that's actually going to give us 12x squared minus 9x equals 0. So this subtract 6 on both sides gets rid of these 6's. And now what we can do is, as you can see, this is a 12 and this is a 9. These are both in the 3 times tables. So if we divide by 3 on both sides of the equation, we're going to get 4x squared minus 3x equals 0. And from there we can factorize out x to give us x, open brackets, 4x minus 3 equal to 0. So therefore either x is 0, which would not make sense because this would be 3 times 0, or the inside of our bracket is actually equal to 0, meaning that 4x minus 3 equals 0, or 4x equals 3, or x equals 3/4. Therefore, our x must be worth 3/4. The value of x is 3/4, or you could write it as 0.75. So with this problem, we had areas, and we might have had to find a quadratic here. And what we did differently this time is, if you've got a situation where you've got rid of your constant term in a quadratic, you should be able to factorize out x. So if we simplified here by dividing by 3 on both sides, then we end up here, and you should recognise that both these terms have common factors. Now, if we can try and factorise into one bracket, so we've got this over here, we can factorise to get something like that with one bracket and a term outside, then we would. The reason we have double brackets for this is ignoring this. If it was equal to 0, we would try and factorise, because that would be the simplest way of finding a solution. If we have to use one bracket, or if we can use one bracket, sorry, then we will. So you can factorise out x here, one of your x's is 0, and the inside of your bracket set equal to 0 as well. So this is another way that you could have a problem-solving data issue. So we've got a question now about Caitlin giving it to her friends an equation to solve. She records the time it takes for each student to solve the equation. The data gathered is used to create a histogram. So we're told then that 160 students take between 2x plus 10 and 4x minus 2 seconds to solve the equation. How many students did Caitlin ask? So this would be quite a tough problem-solving question looking at data, and it really does test your understanding of frequency density. So as we're doing a histogram question, it's worth remembering a couple of formulae first. So you should remember then that frequency density is the frequency divided by class width. So where frequency is the total number of people in each section, so represented really by the area of each rectangle, and the class width is the distance between this point and this point. So this is a class, and then the next class width would be the distance between there and there for this rectangle, and this class width would be between here and here. So we need to say, well, if we can find out x some way, then we'll be able to find out how many students there are in total, because the total number of students is going to be this frequency plus this frequency, which is the area of that, plus this frequency plus this frequency. And if we can find out the area, therefore, of each of these, then that will give us the total frequency if we add them all together. So the frequency in a histogram is going to be the size of each rectangle. So therefore, the frequency, if we solve this equation by multiplying both sides by class width, then frequency density multiplied by class width is a frequency, i.e. this length, the frequency density, multiplied by this length, class width, will give us the area of this, which is the frequency. So we need to work out the length for each rectangle and then multiply them together. However, we're told that this area is 160. 160 students take between this and this. So this length here multiplied by this length here will give us 160. That sounds like an equation. So we're going to go this length here between 0 and x over 2. So this length there, which will be x over 2, multiplied by 2x plus 10 and 4x minus 2. So we need to find out what that length is there. Well, that length there is going to be 4x minus 2, take away 2x minus plus 10. So this length here will be 4x minus 2, 4x minus 2, take away 2x plus 10, so minus 2x plus 10. 4x minus 2x will give us 2x, and minus 2 minus positive 10 will give us minus 12. So minus 2 minus positive 10 will give us minus 12. So we'll get 2x minus 12. And we know that this length here, which is x over 2, multiplied by this length here, which we worked out to be 2x minus 12, is 160. So if we expand that bracket, x over 2 times 2x, well, 2 is divided by 2 here, so we're left with just 1, and it's going to be x times x, so x squared. X over 2 times minus 12, so we're going to have minus 12 divided by 2, which is minus 6, and the x. And that is equal to 160. So from this point, you should see we've got a quadratic here, and your instant thought should be to try and set it equal to 0, and then factorize if we can. Remember, if it doesn't factorize, our second order of preference would be using the quadratic formula, and if that doesn't work because our discriminant, i.e. Square root of b squared minus 4ac, ends up being negative because we can't square root a negative number, then we would use the complete the square. So x squared minus 6x, to get rid of this, i.e. turn it into 0, we're going to take away 160 from both sides. And then we need to think, okay, does x squared minus 6x minus 160 factorize? And hopefully you'll see that it does, because two numbers that multiply together to make 160, but add together to make minus 6, will be minus 10 and minus minus 16 and plus 10 would be our two values. So this would factorize to be x plus 10, x minus 16. So we want two numbers that multiply together to make 160, but add together to make minus 6. So minus 16 plus 10, meaning that x is either minus 10 or x equals 16. Now x must be 16 and not minus 10, because you can't here have on your histogram a negative frequency, so it must be that x is 16. So x equals 16, meaning that this becomes x over 2, which is 16 over 2, which is 8. This is x over 4, which is 16 over 4, which is 4. 16 over 8, which is 2. And 16 over 16, which is 1. So now we've got these values here. We know that instead of x, it's going to be 16. 2x plus 10, which is going to be 32 plus 10, which is 42. This value here, which is 4 times 16, which is 64 minus 2, so 62. And this is 8 times x. Well, if you know that 2 times x is going to be 32, and double that and double it again, so it's going to be 64 plus 2, so 128. So now you can work out the size of each of these. Well, you know that this already we've been told is 160. This is going to be 16, which is 1 times 16. Now this is the difference between 16 and 42. So 42 and 16 have a difference. If you do 42 minus 16, then that's going to give you 6, 2, so 26. So 26 multiplied by 4, so that's going to be 100. Let's write it up here. 104. And this area here is going to be the difference between 128 and 62, which will be 66. So 66 times 2, which will be 132. Now what you need to do is add them all up. So 132 plus 160, which will give us 292, and then 104 plus 16, which will be 120. Add them together, and you get 412. Okay, so a lot of students have said that they're finding this sort of problem quite tough, and it is a circle centre tangent to the circle at this kind of point here. It's got a centre at 0, 0, but writing the equation of the tangent at the point P, so writing the equation of this line here, students are finding quite tough. So let's try and simplify a little bit. As it's a circle with centre 0, 0, and this is a tangent at the point 2 minus 4, then you could say that this is actually, you could draw the radius here, and that's my attempt at a straight line. So the radius there at to 2 minus 4 from 0, 0 Before we go any further though, there's a couple of things that you just need to remember to tackle this kind of problem, and that's that the tangent and the radius, so your circle theorem, that your tangent and the radius meet at 90 degrees. Okay, so that's one thing that you definitely need to remember for this problem. The other thing is to link in that, well, if they're 90 degrees, then they're actually perpendicular lines. So you need to remember that if your gradient is m for the normal, so let's go, if your gradient is m, whatever that is, so say 2, then the gradient of the tangent is going to be minus 1 over whatever your gradient was. So the gradient of the normal, so this line here in this case, if it was 2, then the gradient of the tangent would be minus 1 over 2. So that's the gradient of the tangent. So that is really, really important. Two things that you need to kind of remember in order to tackle this kind of problem. Finding the gradient of a perpendicular line, because once we've got that, we can actually just substitute in x and y. As we know it's a straight line, it's going to be y equals mx plus c. So we can just substitute in 2 minus 4 instead of your y and your x. So let's show you how that would actually look. And first of all, you need to find the gradient of r, which seemingly is quite tough because you've only got one coordinate here, but as the origin is at 0, that means you've got one set of values which your gradient of your r, your radius, has. So you've got 0, 0 as one set of coordinates, and then you've got as your second set of coordinates for this radius 2 minus 4. So what we can actually do is find the gradient of that line. Remember, y2 minus y1, i.e. the change in height, divided by x2 minus x1, i.e. the change in left to right, is going to be the gradient. So the gradient of r, the radius, I'll just call it mr, is going to be the change in y divided by the change in x. Well, you've got two coordinates for your radius, so just substitute them in. So y2 minus y1 is going to be the y coordinate for your second set, and it doesn't matter which set you call 1 or 2. I could have called this set 2 minus 4, I could have called that 1, and this one 2. As long as I'm consistent here, you'll get the same gradient. So I've just decided to call 0, 0 as my first set of coordinates. So your gradient of your, let's just go back, the gradient of your radius is going to be minus 4 take away 0 divided by x2, so 2 take away 0. So you have minus 4 over 2, because you're not taking anything away from them. So 4 divided by 2 is 2, so minus 4 divided by 2 is minus 2. So the gradient of your radius is minus 2. If the gradient of your radius is minus 2, then the gradient of the tangent, because it's perpendicular, is going to be minus 1 over minus 2. Minus 1 divided by minus 2 is going to be a positive, because just like a negative times a negative makes a positive, well, a negative divided by a negative also makes a positive. So minus 1 divided by minus 2 is actually just going to be a half. So the gradient of your tangent is a half. So now we've got the gradient of that tangent. We know it's a straight line. So it's y equals a half x plus c. And I've put that in because I know that the equation of any straight line is y equals mx plus c. The gradient of any straight line is y equals mx plus c. So the equation of any straight line is y equals mx plus c. So m being the gradient and c being the y-intercept, i.e. where it crosses the y-axis. So as I've worked out my gradient of this line here to be a half, I can put that in there. Now that all that's left doing, we need to find out c. But we know a coordinate on this line is 2 minus 4. Okay, this is a coordinate on this line, so we can substitute it in. It'll have a solution. So instead of y, as this is, remember, x, then y, it'll be minus 4 equals a half of my x coordinate 2, add c. 2 times a half is 1, So minus 4 is 1 plus c. Take away 1 from both sides. Minus 5 equals c. And I'm nearly there. So we rewrite this with c put in. So it's y equals a half x minus 5. Okay, so yeah, you could put plus and minus 5, but we just simplify because there's a plus here. So it is plus minus 5, but we simplify that by just writing minus 5 because a plus and a minus next to each other makes a minus. So that is the equation of your tangent at the point P. So a right-angled triangle now, and we're looking at finding the value of an unknown given the hypotenuse is 2x plus 1, this length here is 9, and this length here is x plus 3. And hopefully now we're strong enough at our Pythagoras' theorem to recognise that if we were to square the two shorter sides, add them together, it would make the longest side squared, i.e. a squared plus b squared equals c squared. So the hypotenuse is always the longest side, or if you like remembering it as opposite the right angle, then that's fine as well. So as a squared plus b squared equals c squared, we can actually say, well, actually instead of a, let's say x plus 3, so x plus 3 all squared plus 9 squared equals 2x plus 1 all squared. And if we expand this bracket, it's going to be, let's put it over here, x plus 3 multiplied by x plus 3, which would give us x squared plus 6x plus 9, and then plus 9 squared, which is 81, equals, and then over here again, 2x plus 1 squared is the same as multiplied by itself, so that's going to be 4x squared, so let's write that again, 4x squared plus 4x, and then positive 1. Now I've got my numbers I can simplify here, so let's say x squared plus 6x plus 90 equals 4x squared plus 4x plus 1. So hopefully now you can see again that we've got these quadratics on both sides. Let's set them equal to 0, so we're going to subtract from the side with the least number of x squareds, so this side here, so subtract x squared, and that will give you 3x squared, and it gets rid of that. We're going to subtract 6x, because we want them all on the same side as the positive x squared now, so we subtract 6x, and that gives us minus 2x, or negative 2x, and we subtract 90 to give us minus 89. Set that equal to 0, and the first thing we'll try and do is factorize it, and hopefully you'll see that it doesn't factorize, so what we're going to try and use is the quadratic formula. So minus b, so a is 3 here, positive 3, b is minus 2, and c is minus 89. So minus b, so 2 plus or minus the square root of b squared, which is 4, minus 4ac, which will be 4 times 3 times minus 89, which will give us minus 1068 over 2a, which will be 6. So this will simplify to 2 plus or minus the square root of 1072 over 6. Hopefully you appreciate that. This will now be a calculated job, which would give us two values, one with the positive value of this and one with the negative value of this, which would be minus 5.12 or 5.79. And these are actually our two values of x. So x is either negative 5.12 or x would be 5.79. However, only one of these is sensible because, let's just do this in the highlighter, one of these is sensible because here we've got x plus 3. And if you've got minus 5.12 as your value of x, then that's still going to be a negative number, and that's going to be a negative length. So we would say that it would actually be 5.79 as our answer. Okay, so although this has been a problem which required a calculator at the end, this may well turn up with different numbers where it doesn't have to factorize for it to have to be a calculator paper question. It can be a quadratic formula question, which is expected to be in the non-calculator paper. They would, however, tend to use easier numbers than this. They would be square numbers usually. So we're looking at a composite function question now, and we've got this notation f of x equals x squared minus 6. Find all values of x when f of x equals f of x. To tackle this problem, we're going to need to understand composite functions a little bit more. So by f of x, what we're actually saying is we're going to get our equation f of x, which is here, and we're going to replace the x value inside it with whatever's to the immediate left of this term, which is f. So the f equation, this equation, has its x value replaced by the f equation. So what that means is we're going to actually get x squared minus 6, and that, which is our f equation, is going to replace the x here. So x is that, so we're going to square it and then subtract 6. So we've got our f equation, and this means that we're going to put it, instead of x, we're going to replace it with x in the f equation. It might be easier to understand if you had a g equation. So if we had a f and a g equation, the g equation was x minus 2. If I was to say, alright then, what is going to be the expression if you were to have g of f of x? Well, I'd get my f equation, and I would replace it with the x in my g equation. So I get my g equation would be x minus 2, but instead of x in the x minus 2, I'd replace it with x squared minus 6. So my f equation has been put into my g equation. So instead of it being x minus 2, it would be x squared minus 6 minus 2, which would simplify to x squared minus a. Okay, so that would be g of f of x. If I had f of g of x with these same equations, it would be my g equation, which is replacing the x in my f equation. So instead of it being in my f equation, instead of it being x squared minus 6, it would be x minus 2 all squared, and then subtract 6. Okay, so I'm replacing in my f equation, I'm replacing it with the g equation instead of x. Okay, so if I had f of x, and you could get as far as things like f of x, where you put in the f equation, then doing that again to the f equation. But this one's going to be a little bit easier. We've got the f of x, which we've got to work out. Well, f of x is going to be my x squared minus 6, which is in place of the x in x squared minus 6. So, to write this as another way, you do expand this bracket by making it x squared times x squared, which is x to the 4. It's minus 6 times x squared, minus 6 times x squared to give you minus 12x squared. And then minus 6 times minus 6 to give me positive 36. But then we've got this on the outside, which is subtract 6. So we've got x to the 4 minus 12x squared plus 30. So that's f of x. Now we've got to make it equal f of x. So x squared minus 6 equals x to the 4 minus 12x squared plus 30. My highest power of x is over here, it's my x to the 4, so let's try and keep that positive. So we've got to subtract x squared and add 6. If we subtract x squared, we're going to have x to the power 4 minus 13x squared. And then instead of So to get rid of my subtract 6, we've got to add 6. So add 6 to both sides will give me plus 36. Set that equal to 0. So with that, I'm just going to get rid of all this because we're going to do something which isn't a trick, but is a very, very helpful tool when you have something that looks something like this. And we've got these powers of x which are even numbers, and we can kind of do quite a clever thing. And instead of, let's say, instead of x squared, what about if we saw this? We could say, actually, instead of x squared, let's call that a. So instead of x squared, we've got a here. Now, if we say that x squared is actually a, then we can still find what x is by square rooting a. So we square root both sides here, you'd actually find that x was the square root of a. So, you know, algebraically it makes some sense and we can substitute later on. But if we said x squared equals a, then that means that x squared multiplied by x squared would be, well, at the powers, and it would be x to the power 4. Whilst we've said x squared is a, then this is the same as saying a multiplied by a. A times a squared. So that means that what we can actually do is go over here and say, well, actually instead of x4, so x to the 4, which you got from the above, that's the same as saying a squared. Well, instead of x4, let's make this a quadratic. Let's go, okay, that's a squared, which means that this would be minus 13, and instead of x squared, it would be a, and then add 36. From here, you can actually factorize it. So now we've got a, two numbers that multiply together to make 36, but add together to make minus 13, would be minus 9 and minus 4, or negative 9 and negative 4, meaning that my values of a are either 9 or a equals 4. Now, as a is minus 9 or a equals 4, we can say, well, actually we said earlier that x squared is a, so it's not fair to say this. Let's go x squared equals 9 and x squared equals 4. Now, if we square root both sides, x is plus or minus 3, so positive or negative 3. Or if we were to use these values, square root both of them, x is positive or negative 2. And that, these are all the values of x for this. Positive, negative 3, positive, negative 2. So, looking at some attempt at maybe some, not composite functions, but we're setting a couple of functions equal to each other, which hopefully won't throw you guys. If I've got f of x, which I've got up here, and g of x being this, if we have this sort of problem, what we've got to do is set them equal to each other, so we know that 10 minus x squared equals, so that's our f of x, equals this. And this, if we expanded it, would be x squared plus 8x plus 3x plus 24, which simplifies to x squared plus 11x plus 24. Again, now we've got a quadratic, and like we said in one of the previous examples, let's try and get rid of our x squareds, which are the least. So this is minus x squared, this is 1x squared, so we want to get rid of this minus x squared. So we're going to add x squared to make it 2x squared, but then we're also going to take away 10 from both sides to get rid of the 10. That's positive on this side. So plus 11x, and then subtract 10 from 24 and you get 14. Now we want two numbers that multiply together to make 2 times 14, which is 28. So we want two numbers that multiply together to make 28, but add together to make 11. And so those are going to be 7 and 4. As you want to make positive 11, it's going to be positive 4 and positive 7. So 0 equals, open brackets, x plus 7 over 2 and x plus 4 over 2, and simplify if we can. So that's going to be 0 equals 2x plus 7, as that doesn't simplify to make a whole number, and x plus 2, as 4 divided by 2 is 2. So therefore our two values of x are when this bracket equals 0, so x equals minus 2, or when this bracket equals 0, and this bracket equals 0 when 2x plus 7 equals 0, so 2x equals minus 7, divided by 2, and x equals minus 7 over 2.